YouTube. All right, so we're looking at number 5. Is this always there? That's so annoying. Okay. Number 5. Come back. Okay. It says GC is the bisector of BCA. Abby just asked me a really good question. She said, is that the only one we know? Because of how it's marked, yes, that is the only one we know of. These little marks right here show me that the segments are congruent, or those angles are congruent. So I know that this big angle BCA got split by this segment GC. You may want to turn so you can see the screen too. Oh. That's why everyone's looking at you. Yeah, it's not just because you're the new kid. This is Max, guys. He's new to our class. Hi, Max. Okay. Kamar, do you want me to talk more about that one, or is that good?
So whenever we want to name an angle bisector, it has to be a line?
It has to be either a line or a ray.
Okay.
Good question. This one, I'm not going to put an arrow with it because it ends. It has a point that it ends at. Good question. All right. Anything else on this part of the page you see? Yes, Nolan. So that's what Abby and I were talking about. That one won't work because I don't know if this angle and that angle are congruent.
So they have to be congruent?
Yes. Remember bisect, angle bisector. Bisector splits it into 2 equal pieces. Awesome. Okay, what about, let me scroll down. Let's look at 4 through 8. I'll go with this diagram. So I'm going to zoom just so you can see the diagram and all the way to 8 and a little bit of the top of 9. I know that there's a lot of small writing up there. Check your box. If your box isn't the same, then let me know and I can talk about it. Hey, Max, if you go to our Schoology page, you should be on our Schoology page now. You found the document. Good, you're on the document. Perfect. All right, anything I can talk about while we're here on 4 through 8? Number 8, good. Number 8 is the one that says measure of ACD is 60, measure of DCH is 20. So let's go write that on my picture. DCH is 20. DCH. This guy right here is 20. And then ACD is 60. So this whole angle right here is 60. ACD is 60. While only CHD is 20.
Also, okay.
Good. Minus them, I get 40. So the 2 little angles, 40 and 20, are going to add to be 60. So we subtracted to 5 those. Good question. Let me zoom back out. Ooh, come on. All right, what else can I answer on this section? This is the key to this. I don't post normal homeworks online, but I post review answers online. But this is something that, like, when I meet with anybody one-on-one, we can pull this up and talk through. Yep, Caleb? How do I set up the equation for number 9? Great question. So this is a new diagram. Are we all done with 4 through 8? Good, okay. So I have a picture here. Let's see. Let me just erase everything. So it says in the figure on the right, we know that PQS is equal to 7x minus 4, and we know SQR is 36. The other thing it tells us is that PQR is 4x plus 47. PQR, that's the whole angle, and that equals 4x plus 47. So the whole angle is 4x plus 47. That goes in here. We want to find another angle. Before I find that angle, I have to find out what x is. I know that the little pieces, this yellow angle PQS plus SQR are equal to the pink angle, the PQR. So I'm going to add the 2 smaller ones to equal the whole one. So that's why I set up, and I even wrote it over here in terms of segments. I knew that the whole PQR is equal to PQS plus SQR. And so then I just substituted the values in. 36 was SQR, PQS was 7x minus 4, and then the total, the whole, was 4x plus 47. Again, if I had to bet, that's probably the hardest part for a lot of us. Once I simplified and solved, I got x equals 5, and then I plugged that in and got PQS equals 31.
If you don't write the M angle, is that wrong?
Technically, yes. I don't often ask you to write that, though. A lot of times my answer will have this already and then have a blank for you. It would also not be completely wrong. It would be like half credit. All right. All right, I'm going to show you number 10 as well. This one says A, B, C are collinear with B between A and C. Before I do anything, I drew it. I drew a line over there on the left. It says A, B, C, and then I labeled the segments AB as 4x minus 1, BC is 2x plus 1, and AC is 8x minus 4. Then I substituted in. After I wrote my expression in terms of x's, I wrote, or in terms of segments, excuse me, I wrote AB plus BC equals AC. And then I substituted and solved. And then it wanted me not to just to find x, it wanted me to find AB and AC and BC. So then I plugged in for those guys. Questions on that? Doing okay? Okay. I'm going to scroll over to the back. This is using this picture over there on the left. And most of these didn't have really a lot of work. A loud video.
Number 7, if you wrote it M-O-M-P, is it wrong?
M-O-M-P. Let's see. I'm looking at M-O-P. That's this angle right here. Yes, technically, because O is the vertex. So O should be the one that's they're sharing.
Can you kind of demonstrate number 6? Because like it kind of confusing. Because I thought like I was confused on like the question.
Absolutely. So it says I'm looking at angle number 2. And so I had to figure out what letters go with that. What fits angle number 2 is P and M and R. It's all of this space in here essentially. And so my vertex is P. That's where the number 2 is. And so I'm starting with P on each of them. On one of them, I have to go to M to complete that angle. And the other one, I'm going to R to complete the angle. So 2 is on the inside, and this is where the angle is. Does that help, Kumar? Good. Any other questions? All right, should I scroll down a little bit? On 11 through 14, you don't need to use a protractor on that. I didn't give you a protractor. I didn't ask you to buy one for this course. Honestly, we don't use them that much. So I just wrote obtuse, acute, and right. That's good enough for me. If you did use a protractor, good on you. I just personally don't own one, so I didn't use one. I used to have one a long time ago. Okay. Anything else? Keep going. We had 2 more. Okay. So this description right here is what helps me set up both of these guys. So I'm going to walk through it. I'm going to get rid of this highlighting over here, but not my statements because I think that those are helpful. It says in the figure, CB and CD are opposite rays. So that means that I've got a straight line right here. Let's make that yellow. This is a straight line. So that means that all of those add up to 180. This is all 180. Then it says that CE bisects DCF. So CE, I'm going to highlight it in orange. CE bisects DCF. In green. So that means if it bisects that, then these two segments are congruent. This segment right here and this segment right here are congruent to each other. I use this little mark right there to show that. Do you see how I did like one little curve on both of those angles? That means that they're the same. It's just like if I did this on my segments. You see how that's my congruent mark for them? For angles, it's hard because there's not just like a straight line I can make. I just kind of curve around to get there. All right, and then it also says that CG bisects FCB. GC bisects FCB, excuse me. So that means that this blue angle and the pink angle are going to be congruent. And I use a little pink, or the little two curved lines in order to show that. I know that's a lot of color, but what that's saying basically is that I'm dealing with these two together because they're both congruent to each other. And then I'm going to use these two together because those are congruent to each other. And luckily, that's what it gives me in my next problems. The first one says, if DCE is that top angle 4x plus 15, and then ECF is that middle one, 6x minus 5, then I want to find what DCE is. So what I had to do was find x. Since those pink angles are congruent to each other, I just set them equal. Set them equal to each other. Got x equals 10. And then I plugged it in to find DCE. Similarly, for 16, it's just using the other two angles, which I think I highlighted in orange on the graph. I'm just setting those two equal to each other and solving. I'll zoom back in, but those are just congruent angles because that's what they're asking me about. Can I talk more about that, or are we okay? Thumbs up. You don't have to be like 100% with this, but like, are we pretty good on questions right now? Okay. This is also one of the ones that like, I'm gonna get all your homework ready to you and back to you on, I'll do that for the day that you review. If you want them tomorrow to look at them all weekend, let me know and I'll have them ready and pulled aside and give to you if you want to come see me sometime tomorrow. If you know you're not going to study your homeworks over the weekend and you turn in paper, then don't worry about it. You also can pull these up on your iPad and do it on Notability and just retry some of these problems again. And then using your homework, you can have the answer. So those are another good thing to do to help practice and study for the test. I'm going to come collect your homework now. If you have a paper, make sure your name's on it. If you did it on your iPad, please turn it into Schoology. Remember, if you don't turn it in, it's not credit. And then we are going to start going over, did we finish lesson 1-4? Did we finish this problem yesterday in this class? Yeah? Okay, then we're going to go straight into 1-5. Okay, I'll pull that up to the front. So if you have a paper homework, turn that in. If you want paper notes, get those from me. We'll do both of those at once. If you're going to use your iPad, that is also fine. Just set out. You want to take your notes or online? Online?
before on mine?
Okay, if you change your mind and it's blank, just give it back. If you change your mind and it's not blank, just put it in recycle. Right. So I'm only available before and after school.
Okay.
I can come in as early as you want me to. I can stay as late as you want.
Okay. Okay.
You just tell me if you have a preference, when's good for you, and I'll make it work. I'm super available right now. Come spring, I will not be, but right now I'm super available. Okay. We got our homework, turned it in. We're looking at our notes. So we're doing angle relations today. We're talking about how angles are related to each other. Ooh, come here. Okay. So the first type of angle relations we're going to learn are something called adjacent angles. What does adjacent mean, like in real life? Next to? Good. So we're looking at angles that are basically next to each other. I'm going to write next to just in case I forget later what adjacent means. Next to. However, in addition to just being next to, I've got a couple other things going on. They also have to share a vertex. That means that they have to have that common initial point of the angles has to be the same. They also have to share a side. So let's see, let's draw a picture. This could be adjacent angles. Super ugly adjacent angles, but it's adjacent. Okay, that's a little bit better. These share a vertex, see that they're at this common point there, and they also have a side in common. This side right here is shared by, and let's shade just so we can know what we're talking about. I've got this purple angle right here, and I've got a green one over here. They share the vertex, which is orange, and they share the side, which is yellow. And then they have no common interior points. The purple and the green don't bleed onto each other. They don't overlap at all. They have no common interior points. Something that helps me think about it is there an overlap? So we don't want an overlap of points or of their lines. These are a good example of adjacent angles. What I'm about to give you is a ton of bad examples of not adjacent angles. So I'm going to show you all of the possibilities that are not adjacent angles. So we're going to go through these pretty quickly. You may want to shade with me, or you may want to just write next to it why they're not adjacent. That's kind of what I'm looking for. So this first one, I've got this yellow angle, and I'm not taking time to name it just because I want us to kind of breeze through it. So I've got a yellow angle and I've got an orange angle. Are they adjacent? No, why not? They don't share what? They don't share, well, they don't share a vertex. So there's no vertex. Common initial point is, I think, the I word I wanted from you. Not interior. Common initial point. There's no vertex that they share. They do have a side in common, but that doesn't relieve them. And they also have no overlap, which is good, but that still doesn't help them. If they don't have a vertex, doesn't count. Next one, I'm looking at this one at these two angles. I'm looking at this orange angle right here, and I'm looking at this pink one right here. What's my problem here? They don't share a side. They do have a vertex, and they don't overlap, but I've got all of this space in between it. They do not share a side. I'm going to write no shared side. Okay. Next one. I've got a green angle right here. I'll zoom back out in a second if I'm moving too fast. And I've got this purple angle over here. What's my issue on the green and purple angles? They overlap
And they don't share vertex.
and they don't share a vertex? Is there anything else that I have a problem with? They don't even share a side. They do nothing, right? They don't even cross one of those off. So there's all the problems. Everything's a problem here, right? No shared vertex. No shared side. And yes, overlap, which overlap is a problem. Good. We are full of problems on that last example. All right, we keeping up so far? 2 more examples of bad, not adjacent angles. I have a gray one over here. And I have an orange one over here. What's my problem? They don't share a vertex or a side. No shared vertex or side. They don't have any overlap, which is good, but they're not next to each other. They're not sharing a vertex or a side, so we got to keep moving. And then this last one, this is an interesting one, and this is one of the more common mistakes that we make. If I have this green angle right here, there's such patriotic music going on. And then I have, I don't know, this pink angle right here. What's my problem here? They overlap. All of this that I just spent time coloring is an overlap, right? They do share a vertex and they do have a shared side, this one right here, but because of all the overlap, they're not adjacent. Lydia, question?
Why did only the pink go with the green and not the green go?
The green could have gone over. I could have drawn other angles. That was just the 2 I decided to highlight in this one. And we could have made angles that were adjacent in here, right? If I didn't color all of it, I could have just done like the pink right here, and I could have done the green over here. Are these adjacent? Yeah, right. This is a good example. This vertex, this side is the same. There's no overlap. The reason I have this big line though is to remind myself to color over all of one of them to show that like the whole thing and then something inside of it, those don't count as adjacent. Okay, any other questions? Just gonna erase this like that. Okay. All right, now we've got a couple vocabularies. So, oh yes, Caleb.
So if it's not the line,
If this big line wasn't here, then I would have assumed they were the 2 angles next to each other, and that would have, yes, been adjacent. Good question. Okay, I've got a couple more vocab words for you, and these are what we call relationships between angles. So angles whose measures add up to 90 degrees are what we call complementary angles. Complementary. Complementary angles add up to 90. And then we use it in a noun form. If I say, I've got the angle 20, its complement is 70. The complement, or the angle that will make 20 get to 90, is 70. We don't really use complement that much. We talk about complementary a lot. We don't really ever say complement, but I like to bring it up now. The other one is 180. 180 is a really important one. And if I have 2 angles that add up to 180, we call that supplementary. Supplementary. And thus, this we would call the supplement of 120 is 160. No, the supplement of regular 20 is 160. 20 plus 160 add up to 180, so we say it's the supplement of. So I'm going to zoom in and say supplement. Okay. Another relationship we're going to talk about is about adjacent angles whose non-common sides are opposite rays. We call that a linear pair. So let's look at this example. So I already drew one out for you. Sorry, linear pair. I ran away before maybe some of us could write that down. Linear pair. I've got this picture right here. Let's label it. We're going to call this point G. We're going to call this point E. We're going to call this point O. And we're going to call this point M. It spells geome, like geometry. We do a lot with points and letters, and so sometimes I like it to spell something fun. Okay, so my opposite rays here are EM and EG. So I'm gonna write that over here. My opposite rays are EM and EG are my opposite rays. Opposite rays form a straight line, and what did we call a straight angle? What does its angles measure up to be? 180, good. So they should be 180 right here. This should equal 180. Good. That being said, now I have two angles that are on this line that add up to 180. So I've got one angle that's OEM, and I have another angle that is GEO. And they add up to the straight angle, or 180. So I'm going to write this over there to the side. I've got measure of angle OEM plus measure of angle GEO, and they add up to the whole length GEM, or 180. Measure of angle GEM, and next to that I'm going to write 180. One other thing before we move on, what's my shared vertex of these adjacent angles? E, very good. E is in elephant. E is vertex. Bless you. And what's my shared side? What's the side that the two angles butt up against? E-O. E-O. That's why sometimes I like shading it, and I know some of us use our pens and papers and not the iPads. I sometimes shade on my pen and paper too, because I can see where the shading connects, and I'm like, oh, that's where the angles meet. That's the shared side. Sometimes the visual is what helps me. So E-O is shared side. The one reason that the lines are different is that they have two arrows, and you can put a point like that. You can do that if you want. I just don't put an arrow, and that helps me know. But if you need something to help you distinguish, that's fine. You can do that. Okay, anything else I want to write here? Nope, okay, moving on. Next it says, how is supplementary different than a linear pair? Anyone think they know? They both add up to 180, right? The one difference is that supplementary angles don't have to be on a line. Linear pairs have to be on a line. That's the definition essentially of a linear pair. There are two angles, adjacent angles on one line. Supplementary doesn't have to be. So I'm going to write for linear pair, they must be adjacent and on one line. Supplementary, on the other hand, refers to a relationship. I can have supplementary angles wherever I want. I can have an angle over here that's like 50 and an angle like 3 doors down that's 130. Those still add to 180, so by relation, they're supplementary. It's like, even though like you have, maybe you have a sister or brother, they're not sitting next to you, but they're still your sister or brother, right? That's just a relationship that stays. Linear pairs are supplementary by definition, but they have to be next to each other. In supplementary, they don't have to be next to each other in order to do that. So supplementary, I'm going to write relationship, if I can. Keep going. Relationship. Okay. All right, couple, sometimes, always, never. Angles in a linear pair are blank supplementary. It's going to be always. Always, always, always. The reason it is always is because in order to be a linear pair, they're adjacent and they're on one line. And one line means 180. What about if I flipped it though? Supplementary angles blank form a linear pair. That one sometimes. We play this fun game in geometry sometimes where we like have the same sentence and we just flip two words in it and it's a totally different meaning. This is one of those cases. Angles in a linear pair are always supplementary. Supplementary angles sometimes form a linear pair. Sometimes. All right, flip your sheet over. We're going to learn one more type of angles. These are two non-adjacent, so they are not next to each other, angles that are formed by intersecting lines, and they are called vertical angles. Vertical angles, that's a V-E-R. Vertical angles. They are non-adjacent, so they do not share a side, but they always share a vertex. In this picture, this angle and this angle are vertical angles. They are essentially across from each other when you have two intersecting lines. I'm going to label these angles 1, 2, 3, and 4. And let me actually color them in so that we can see what we're talking about. There's 1, there's 3, and then 2 and 4 are also vertical angles because they're across from each other. Okay. So those guys are vertical angles. Let's do something. Let's look at a linear pair. Let's separate out. Let's focus on this line separating them. 1 and 2 are a linear pair because they're on a straight line. Cool? Are we in agreement with that? That seems right. What if I call angle 1 60? If I told you angle 1 was 60, how much would angle 2 have to be? 120. Why, Abby? Because they add up to 180. 60 plus 120 should add to 180. Angle 1 and angle 2 add up to 180. We're using our linear pairs. So we can say angles 1 and 2 are a linear pair. We also could move my line and look at a different set of linear pairs. What if I did this line and looked at 2 and 3? 2 and 3 are also a linear pair, right? They're on their own line. If 2 is 120, what should 3 be? 60. And then we can look even just across the line. I've got angle 1 is 60. What should angle 4 be? 120. Do you notice anything special about my vertical angles, the 2 yellow ones or the 2 orange ones? They're congruent. And that is always true. Always, 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 always. Vertical angles, by definition, are congruent. I want you to skip this example really quick because I want to jump down here and write something in this box. One of the things people struggle with in geometry is that there's a lot of like looking, finding, exploring things. This right here is like straight fact that we just need to like memorize and know. So I'm going to highlight this box in yellow, and this is something that like we should be able to like spit out word for word at any time. The first one says if 2 angles form a linear pair, then they are, on the front side, we decided they were supplementary. If I like see you in the hall and I say linear pairs are, you should be able to say back to me supplementary. Like not even in the geometry mindset, like that should be so embedded in your brain that you could say that at any time. And then we just learned that vertical angles are congruent. Those are true statements that we're going to use for the rest of the year that we learned today. Vertical angles are congruent, linear pairs are supplementary. And again, that should be so in your head that if I see you at any time and I'm like, vertical angles are, you should say congruent. Billy? Yep. So I'm going to fill this in. 130 goes here. Those are congruent. What should these angles be? Say again? 50? Because they should add up to be 180. Good. All right. I'm going to keep that highlighted. Let's go back to this example I skipped and let's work through this guy. What is going on here? What is going on here? It says name a pair of vertical angles. We got to figure that out. What did you say? I heard 3. What else did I hear? 5. Good. That's it. That's it. Remember that vertical angles are just 2. 2 vertical angles. Linear pair, just 2. I can't have 3 of any of those. Yes, yes, yes. So, okay, so if I were to highlight the lines that I see on this page, I've got this line right here, and I've got this line right here, and vertical angles are formed by 2 intersecting lines. And so those those lines intersect, and I'm left with 5 and 3 are across from each other. Technically, the space that's 4 and then 1 and 2 are also across from each other, but I can't have 3 angles that are a vertical angle. It's only 2. The ones right across from each other. If this was a mega angle up there, it would count as a vertical angle to 4, but since it is not, it does not. So I'm going to write, for my vertical angles, I'm going to write 5 and 3. And then for any others, I'm going to say no. It would be angle 4 and something, but since it's angle 1 and 2, it can't be 2 angles essentially. It must be 1. So if angles 1 and 2 together were just 1 angle, or if they were named with points, I could make that work, but since they're not, I can't make that work. Okay, what about a linear pair? What are 2 angles that are on 1 line? If you're not even sure where to look, let's highlight a line and see if we can find 2 angles on that line. So I'm going to highlight this line right here. If I look on top, 1, 2, 3. Oh, shoot, that can't be a linear pair. That's too many. What if I go down here? 1, 2. Oh, that works. 4 and 5 are a vertical angle. Or not, sorry. 4 and 5 are a linear pair. Are we okay with that? I believe there's another set of linear pairs. Can you give them to me? Sorry. I hear 3 and 4 a couple times. Let's look. Say I highlight this line. Yep, 3 and 4, they're along the same line. That works. All right, are there any more or is that it? We want there to be more, right? Because we have this line right here. We want that to keep going, but it doesn't. And so since it doesn't go fully through, this, like right here, this 1 and 2 don't make a line, and neither do 1 and 5. This is another common mistake. People want to say 1 and 5 work, and it doesn't. So good, we get our mistakes out here. All right, what about a pair of supplementary angles? What does supplementary mean again? Add up to 180, good. So I'm gonna write, and this is just for me, I'm gonna write 180 next to supplementary in my notes, just in case I forgot. What are 2 angles that add up to 180? What did I hear? 5 and 4. Yep. Good, Kate. Those add up to 180. Those are on the line. Could I have written anything else? Did I actually even need to look at the picture? Or could I just have looked at my other work? Why could I have just looked at my work? What did you say? If they're vertical, they're formed by lines. I'm looking for the other one. Linear. If they are a linear pair, then those are supplementary. So vertical is not necessarily wrong, but don't think that they're supplementary because they're not necessarily. So I could have done 4 and 3. Good. And then are there any complementary angles? What does complementary mean again? Add up to 90. Good, Kamara. Add up to 90. Are there any that add to 90? Why is it 2 and 3? Which one's the right angle? 2 and 3. And what else is the right angle? Just 1. It gave us 1 as the right angle. And so if 1, 2, and 3 are all in a line, then that means 1 is 90 and then the other 2 are also 90. So 2 and 3 are my complementary. Awesome. Let's keep rolling. We got a couple algebra problems I want to do before we have to leave. The first one says, find the measure of 2 supplementary angles. Stop. What is supplementary? 180. Good. If the measure of one angle is 6 less than 5 times the measure of the other angle. All right, let's draw a picture. There's a line. Now it's a linear pair because there's 2 lines now, or 2 angles, excuse me. If it says the measure of one is 6 less than 5 times the measure of the other, we need to use a variable to represent the other angle because I have nothing else to do with it. So let's just use x. We'll just say that angle is x. I don't know. Now, how do I write 6 less than 5 times the angle in terms of x's as an algebraic expression? We don't honestly spend a lot of time on it, but I know that questions like this are on tests and quizzes. So if you have a hard time with putting this in an algebraic expression, let's practice it a little bit. Most of it will be a number times x and then minus or plus another number. That's just a general rule of thumb. And we know that these are supplementary, so they add up to 180. So I'm going to write an equation. Who can write one for me? Perfect, Kate. 5x minus 6 plus x equals 180. The 2 small angles add to be the whole angle. So I'm going to combine like terms. 5x plus x is 6x minus 6 equals 180. Add 6 to both sides. 6x equals 186. Divide by 6. X equals 31. All right, and then that's asking us to plug in, blah, blah, blah. I don't want to plug in right now. We can find those angles later. Can I start setting up number 2? Okay. We have x's and y's. I want to see if I can make an equation with just my x's before I deal with the y. How are these 2 angles related to each other? Vertical and vertical angles are? Caleb? Is that a hand or just a strike? Just, now you're all bashful about it. Yes, Billy. Congruent, thank you. Vertical angles are congruent, so I'm just going to set them equal to each other. 3x plus 20 equals 5x minus 50. Come on, iPad. There we go. And then we can solve. Minus 3x is 2x. Add 50 is 70. 35 equals x. Also, guys, I kind of fly through the algebra. So if the algebra part, if you're like, I got the equation and I don't know how to get the answer, let me know and we can sit down maybe sometime outside of class because that's what I already assume you guys know. All right, last, now I'm just going to pick one of my x's. Let's say we'll pick the 3x plus 20. How does that relate to y? What's my relationship between 3x plus 20 and y? Caleb? Yes, and what's the special word that we learned for that? Caleb said if we add them up, they have to equal 180. Next? No. Abby? Supplementary. And then what's the other word that we learned that are also supplementary when they're adjacent angles on one line? Supplementary angles on one line are also called linear pair. Very good. So these are supplementary angles. Let's add them up and set them equal to 180. Very good. 3x plus 20 plus y equals 180. Let's stop. We found x. Plug that in. 35. Ooh, I'm getting lazy. Okay, let me retry that. I really tried to squeeze it and it did not work. All right. So I multiply those. I get 105 plus 20 plus y equals 180.
As we come to the end of the day, let us pause for prayer. Lord, I surrender myself to you. Take care of everything.
Everyone pause.
In the name of the Father, Son, and Holy Spirit. Hail Mary,
Full of grace, the Lord is with thee. Blessed art thou among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death.
In
Amen.
the name of the Father, Son, and Holy Spirit. Amen. Class is ended. Our first wave can go in peace. Our second wave will be dismissed as soon as traffic allows.
Awesome. Oh, if you want a paper homework, let me give that to you. It says say 50.